Lewis dot structure tells you what? They can't hear you. They can't hear you on the recording. What else? Evelyn can do all the questions. Lewis dot structure can tell you the molecular shape, and it also tells you the number of electronic domains, which is also part of electronic geometry. Correct? Okay. What does it tell you about the bonds specifically, Lewis dot? It can tell you the type. So a Lewis dot structure can tell you if you have lone pairs. It can tell you if you have a single, double, triple bond. Then you can use that to determine the molecular geometry, right? So that's one approach. And Lewis dot structures are a really good approach. But what they don't tell you is they don't tell you why. Why do bonds come together? They tell you that when they do, and we can make the assumption that they do, they'll probably have this type of bond. They might have this number of lone pairs. So what we're going to talk about is valence bond theory. And what valence bond theory tells you, where its strength lies, is that it tells you how strong a bond is. And the way it does this, it predicts the strength of a covalent bond based on the overlap of orbitals. Like that's its key. Somebody asks you what's valence bond theory. It is the theory based on the overlap. And you might be saying, well, what do you mean overlap? Remember, you have S, and what does P look like? 3 figure eights, where they look just like this. You have a PX, a PY, and a PZ. And we usually draw them together, but then we could call this PX, PY, and PZ. And that's based on the orientation. Is it in the plane or coming out at you? And so what we mean by overlap is the electrons sit in these, we call them nodes. They sit in these nodes. And by me drawing the electron as one pointed up and one pointed down, what does that symbolize again? The spin. You all know this. That's right. That symbolizes the spin. So what valence bond theory is saying is that when bonds come together based on the overlap of those nodes, if you have one electron pointed up and one of the opposite spin pointing down, when they overlap, that's when a bond will happen. So think about if you had a party and you have everybody outside and you have a party and you got the music going and it's a really fun party. And you have all these people randomly outside. And then you say, everybody come into the party, come into the basement, wherever we're having the party. All of these people gather, imagine these are the electrons, they gather, and then you say, okay, grab the nearest partner and dance. And that's what they're gonna do. They're not gonna walk through looking for someone to dance with. They're gonna grab the person right next to them and start dancing. Now, what if this is a dance that requires closeness? Like, let's say this is a tango or a salsa, right? They come together, they hold hands, and then they dance. And now you have a combination. That's what valence bond theory is saying. Proximity of two dance partners, and then when they start to dance, how close are they dancing with each other? Now, to understand valence bond theory, you need to understand that there is a difference in atomic orbitals and molecular orbitals. So what is the electron configuration for carbon? We had 1s2, 2s2, 2p2. And what this translates to is energy levels. So we have a 1s that has 2 electrons Then we have a 2s, and then we have a 2p. We're going to call it 2px, 2py, and 2pz. We have 2 electrons in our s, and in our p's, we have this. This is the atomic orbital of carbon. It talks about where the electrons fit and in what energy levels they're in. This is not molecular orbital. This is atomic orbital. This is carbon not dancing. This is carbon outside the dance hall waiting, not entering the party yet. So if you look at this and you say, which electrons can form a bond? Which electrons are available to dance? You would think that carbon only has 2 spots to dance with. This electron can find a partner, and this electron can find a partner, can find someone to bond with. But we know that's not true. We know that carbon can form 4 electron domains, 4 bonds. So why is it that in the atomic orbital, it only appears that they have space for 2? Because that is carbon by itself. And that's where valence bond theory comes in. Valence bond theory comes in and says, when an atom is going to form a bond, a molecular bond, it then shifts electrons around and moves around to make space to get maximum overlap to be able to bond with other atoms. And it does that using something called hybridization, which we're going to talk about in a separate video.